Portuguese, but I can come back to English. So this was a very simple example. I'm going to probably the hardest example we have done, which is a project developed for the Santander Bank in close to Madrid in Spain. This was a challenge for the visitor center. 6,000 people work in this financial city, and they wanted something really, really new. This was done about 2 years ago, and we imagined how it would be a visitor center like 10 years from now. And we created, to start with, a number of robots that speak in Portuguese, Spanish, and English. And they receive people and take them where they want to go.
And so the outcome of this robotics is that
they also, when they are idle, they play music and they dance. We have some choreographies for them. They also go they go to the walls to be charged electrically if they need to. And this is an illustration of Y-Vision at its best, or basically software that handles a number of devices that have sensors, processors, and actuators. So this is an example of swarm robotics, and it's a new way of looking to interaction with the world, where actually these are the most intelligent objects, or they can be the most intelligent objects you can imagine. Of course, there are many other developments in robotics, but this is one. But anyway, in this case, in this space, there were many other forms of interaction, and one of them is this one. It's a wall that's about 20 meters and has all kinds of information, and where you have gesture-based interfaces, but also multi-touch and so forth in a big scale. And another way of looking to the world is to have a model, a 3D model, a physical 3D model, and use augmented reality to explore that 3D model. Anyway, I'll leave you the presentation, and you have links to all of these videos.
And we added a digital layer of information, so users could explore.
Okay. And we also have built, this is a very academic exercise, where you explore indoor space. And in this case, you don't have a physical robot, but you have a virtual robot. So this was a European project, and you have someone that helps you and guides you while visiting a space. So this is an augmented reality environment, and you have intelligent agents that recognize you and take you where you want to go. So basically we developed this character in our showroom. It can complement the human guide in a symbiotic way. So you have shadow projection, collision detection, and so forth with this virtual character. It's like some sort of interactive Shrek movie. Can profile the user, adapt his behavior, use lots of machine learning and data mining, and we really think that one day we'll also have some of these characters. We can either use them on a physical way, like robots, if needed, but they don't need to be robots if the intelligence is what we want to have more than any physical attributes. So I covered very quickly, the building block, the microgeography, and I looked to augmented reality and natural user interfaces in some sort of a new way. As software that can guide robots, which are the most intelligent objects you can imagine, and also in a much more disruptive way of creating virtual characters that are not robots, but they have intelligence and interact with you. And it's much more subtle. But when we are talking about the world is your browser, we are talking about physical objects. And I really think that one of the keys is to build intelligence in those objects. We saw the extreme case of having a processor or a smartphone, but in many ways that intelligence will come from printed electronics. And at one of our companies, Invisible, developed a campaign on Kickstarter to enable any maker in the world to, using Arduino code, to create intelligent objects or provide intelligence to objects. This is the first video.
In the beginning of the 90s, Mark Weiser from Xerox PARC imagined a future where computers would not be the center of attention, but would instead blend into the background, integrated into everyday objects and activities, becoming quiet and invisible servants. Moore's Law and similar trends have allowed us to believe that the age of ubiquitous computing would inevitably come, with chips becoming ever smaller, faster, and cheaper. After the ages of mainframe computing, personal computing, and mobile computing, we are now in an age where computers are all around us, improving our lives and augmenting human capabilities. As important as the presence of computers all around us is the question of how these can communicate. The Auto ID Center, led by Sanjay Sarma, drove research on RFID technology to create the architecture for the Internet of Things. Today, the terms ubiquitous computing and Internet of Things are more or less interchangeable. For these visions to reach their full realization, smaller chips and interconnectivity are not the whole answer. Printed electronics technologies bring sensing, powering, and display capabilities that are lightweight, low cost, and provide freedom of form factor enabling computing to be embedded into any object or service. Companies in this field are already applying these technologies in fields ranging from smart cards, toys, medical applications, security, packaging, and logistics. Unlike the internet, however, the technologies that enable the Internet of Things are not as easily accessible. Most printed electronics technologies are only accessible to large companies and R&D institutes. That is why we decided to create Print2. Print2 allows anyone to easily prototype using printed electronics technologies. We believe that by making these technologies accessible, we lower the barriers of entry for innovation in the Internet of Things and encourage new ideas and products to come to life. Much like the openness of the Internet allowed for thousands of startups to emerge with new uses for it, an open Internet of Things is necessary to generate a similar wave of innovation, much like Chris Anderson predicts in his book, Makers, The New Industrial Revolution.
So we launched with several companies around the world. We created a consortium called Print2. We went to Kickstarter, and we had about 500 people around the world requesting those kits to build, for them to build the Internet of Things. One of the most important examples, or I'm going to give two very important examples. One is that by using printed electronics, we have a very light components, and this is an example of what we can do with them. This is a blimp you can do for your house.
In the early 1900s, airships ruled the day. The Hindenburg-class airships, for instance, were over 800 feet long. Today, we find out how to make one at home with Print2. We start off by programming the core module,
one important thing
Come on, man.
is that you can make things with software, but right now you can make it with hardware.
We start off by programming the core module. This program lets you control the Print2 through our motor control app for Android. Print2's modularity makes it really simple to bring it together. Simply plug in the Bluetooth module, the solar cell module to connect the lithium battery, and the motor module to the core. We've used two coreless 7mm diameter motors, one to control altitude and the other to propel the airship forward. We then used a micro servo to control the direction. For the structure, we used balsa wood, as it is very lightweight, and paper clips as the legs. Simply use the glue to put things together and use double-sided tape to place the Print2 on the structure. Now comes the fun. We bought a small helium tank from a toy store and some balloons. You can be creative with the shapes of the balloons. Just make sure they are tightly held together. Ideally, the lift should be slightly lower than the weight of the airship so that you can use motors to control altitude. And there you go! It's ready to take off. Now imagine all the cool stuff that you can add to your airship with Print2. LEDs, speakers, sensors, solar panels, autonomous behaviors.
Okay, so this is one example. And another example is on smart wearables.
Rigid boards are often not the ideal form factor for wearable devices. Benefiting from the flexibility of printed electronics, Print2 allows you to create first prototypes for smart wearables concepts. Print2 comes with a number of inputs and outputs to bring your wearable creations to life. These include accelerometers, temperature sensors, solar cells, electrochromic displays and LEDs, as well as Bluetooth low energy communication. Some of the creations we've been playing around with in the office include an LED signaling device for cyclists, an accelerometer for tennis players, a headbang-o-meter that measures metalhead headbanging performance, and flashy altitude measuring sneakers for basketball players. To increase the wealth of possibilities of Print2, we've partnered with Bitolino, a low-cost toolkit that makes physiological sensors accessible to anyone. Bitolino brings to the table new inputs for your creations, an EMG sensor, a sensor for electrodermal activity, and an ECG sensor, as well as state-of-the-art software to analyze the signals.
Before Bitolino, all of these technologies were inaccessible because of the price. Normally, one system like this would set you back like $10,000 or sometimes even more. And with Bitolino, you have the same capabilities at a fraction of the price. And basically, it's all of what this is about. Wearable devices have one bottleneck, which is the fact that typically when you use a rigid PCB and you have a body which is not rigid, they basically don't match. So bringing electronics to this flexible and printed format can enable projects such as a sheet of paper that you hold with both hands and that can present your heart rate on the fly. And this is something that would be unthinkable any other way.
Following your success at the CodeBits Hackathon, the member...
Okay, so this is another example. So basically, what I'm trying to tell you is that right now, we have the tools to create a world as our browser, both from an augmented reality approach or a natural user interface using very intelligent objects as robots or those virtual agents I mentioned, but also on the object side through printed electronics. There is this dream of having RFID tags. Probably it will not happen because we have not reached a cost lower than 1 cent, which makes it unpractical for many consumer goods. But in many instances, we can have intelligence pointers to the interactions. One very important part I didn't mention on the first video is that using conductive inks on a special pen, you can draw on your paper circuits. You can some sort of built-in if this then that type of interface, which will communicate with your mobile phone. You can build fun objects like the blimp and many others, and you can create smart wearables. So all of these tools, both software and hardware, I think the future will be based on the Creative Commons type of society we are building in. These are a number of small companies around the world which are creating consortia and are producing these new tools. But to have some sort of a solid foundation, I really think that we have to go to a very ancient field like geography and also reinvented it using these microgeography concepts I talked about. So I'm available to questions right now or mails to this address. Most of the materials I showed here are part of what has been developing at Y-Dreams, and most recently in two spin-out companies, Y-Vision and Invisible. If you go to the YouTube, you have exactly 133 videos of projects and technologies and products we have developed. Thank you very much. So, are there any questions? Is someone there?
Thank you very much for your exciting talk. I'm afraid, I'm a little bit afraid, I must admit, because I don't want to look like fighting innovation, and in the first place I'm somebody who has to thank a lot of technologies, at least for positioning, because I'm able to maybe get lost even in my own apartment, so I think it's a great thing to have GPS and so. But I'm seeing like all these virtual reality or these devices, technologies, going into the direction that we tend to switch off our brain. I think I see when I travel and I use a GPS, I don't even look at signs, because I know the GPS is telling me that I have to turn right in 200 meters, and I don't even see if maybe there is something has changed and I believe this is going to be the same in other cases. So when we speak about Internet of Things, I'm gonna find my glasses, so I don't have the risk that I cannot find my glasses in my apartment. But also, we tend, I think, to stop interacting with other people. So I don't need to ask for information because I have my GPS. I don't need to. Sometimes, something which really annoys me is to see people so you go out with friends and you see that half of the people who are with you are using the smartphone to chat, to do other things, and you don't speak with people. So I'm afraid, where are we going now? So is there any control in this? Is there any way that technology itself can help us to still use our brain, let's say, so to speak?
Well, there are two parts to answers to your comments. Of course, that is true. I mean, right now it's embarrassing to go to a meeting where the people are there and everyone is looking to their emails and they are remotely on that room. And I mean, I think the only way to prevent that is to forbid. I mean, you cannot take off your devices. And I really think that that will probably happen. You know, in certain moments, I think you will be forced to not to use the devices because the devices are incredibly intrusive, and people are so used to depend on them. They love, people right now love to be interrupted, And I think that one very interesting area is time management. The problem of being interrupted is not so much of not dealing with other people, it is also because of us. We don't have time to be creative. So I really think that if we learn about time management, we learn that we have to have blocks of time that are interrupted, that are not where we cannot be interrupted. We have to have blocks of time where we are with other people, hearing to other people, and so forth. And in the end, we will understand that that is more efficient than the way we behave right now, more than any other upper kind of control. I think we will realize by ourselves that it's much more efficient not to be interrupted by technology and not being and not interact with others. So I really think that the interaction with others will always happen. Right now there is this phenomenon with hackerspaces and makerspaces and fab labs where people actually meet to develop something together. And the Internet of Things, I really believe that to be developing in that way. So in one way, we are creating a creative commons that is both virtual but also physical. People actually will meet. You know, you look to the maker fairs right now, and there are 100,000 people going to the maker fair in San Francisco. So people love to meet people. So that will not go away. Of course, there are lots of. I was in a neurosciences conference about 1.5 years ago, where someone analyzed, you know, what has been happening to our brains with these evolutions. So there are, of course, there are bad signs, and because we are using all these sort of prosthetic devices, we lose capabilities that once we had. Imagine when we have exoskeletons. I mean, we probably lose our muscles on the legs because we walk much faster with exoskeletons, and that's an extreme case. And you know, and the risk exists. But on the other hand, there is a positive side also. You know, by kids that play video games become much more alert. They can handle several tasks simultaneously and so forth. So, as usual, there are bad and or there are negative and positive developments. But ultimately, it depends on us, you know, and on the leadership. How do we want to our kids to be educated? I mean, like we select or we help to select courses or projects in your local school, I think each one of us can influence in certain manner the development of our children and thus the future. But I'm an optimist, and I really think that in the end the good will prevail.
I hope so. Thank you again. Yes, it was a very, very nice talk. I have a comment which relates to the previous one. I mean, in the world you are describing is plenty of sensor, camera, so which means that to me there is a problem with individual privacy.
Yeah.
You understand? Where you log now into your most common browser, you are already profiled. Right? You open it and you are already directed to buy a book because you, a few months ago, bought equivalent book. So there is a complete aspect of protecting user privacy in this new world. And really, I am a bit afraid that your world is a browser could not be a big browser. You see what I mean?
Well, you lost your privacy already. I can call a hacker and tell you everything about your life.
But I would like to be protected against that.
Yeah,
I would like the research to go in the direction to protect me. Not
well, I mean, I think privacy right now, as it stands, is lost. now people are discussing on how to regain privacy, which is very different. You know, how can you have the right to be forgotten in Google, or you can, right now the fight is not about losing more privacy. We lost it. We have to regain privacy. So the battle is on how to regain privacy, and from now on, I want to remain private and unknown, how can I do it? You know, and I think those are the challenges, not the challenge of the future. The challenge of the future is to regain privacy. It's a different challenge. Right now you don't have any privacy. I can hire someone and you'll get illegally, not legally, but you will get illegally to any of your account anywhere.
And you are not worried of this?
If I'm worried about that, I'm worried like anyone else. That is the fact. You know, what I can now I can think on how to regain my privacy on key aspects. You know, and I think that is the battle we have to face. But for many years, there were people concerned with privacy, and sometimes in the wrong manner, because one of the, you know, I think there is a fight or a struggle between privacy and convenience. For instance, if you go to a site in Portugal to buy something from you know, there are so many levels of security that you lose the convenience. So I think there is always a trade-off between convenience and privacy. And in privacy, there are certain degrees. There are some that I don't care. There are others that are critical. And I think that the discussion from now on. But right now, as it is, you know, it is. Everyone knows that it's a dangerous world. You know, periodically there are some people using my credit card in China. And, you know, unfortunately, the credit card company tells me, "Well, are you in China right now?" Before authorizing the permission. You know, but this is the world we built without any. And I agree with you, with any concern at all. You know, we just built it. And it's wrong in many ways, and right now I think we have to discuss on how to make it better, and you know, and I'm very aware of those privacy issues. I mean, we worked many years ago on location-based games, and we failed miserably because of the privacy issues. People didn't want that the other people knew where they are. So the way to do it, and right now we have a new application, is to be anonymous, totally anonymous, and no one knows who you are. And basically you erase every possible transaction after it's done. But there are drawbacks as well. And if you go to the comments page on any website that are anonymous, you see the problems of the anonymous comments. You know, they are horrible. They attack people, and they are not responsible. So there are lots of trade-offs involved. It is not such an easy question. I have a friend that decided to be anonymous for life. You know, and he has a lot of work to do it. You know, the work involved of not being on the web is unbelievable. And sometimes I don't know if it is, you know, if he's paying the right price. But anyway, it's a good question.
So we need to go on. I would like to thank Professor Câmara for this nice presentation, and we have a gift for you.
Okay.
I have also a small announcement. We will delay the program for 15 minutes, so the session will start at 10:45. I will ask the chairs to start at 10:45. Time for the coffee break. Thank you very much.